Alright guys, today we're going to take a look at the second lesson in Chapter 4. So let's go ahead and get started here. The second lesson is talking about negative exponents. So we just learned about positive exponents in Lesson 1 of this chapter, Chapter 4. So this is kind of building on what we just did here. I'm going to zoom in here so hopefully we can see this just a little bit better. What's this going to do? Let's see. Okay. So let's see. This is asking us here, we're going to skip the getting started part. Really quick, let's take a look at this quick review. So it says simplify the expression below, use an exponent. So I'm just thinking out loud here. If we had all of this on top here, well, let me see if I can scroll over. Here we go. I'm just thinking we could rewrite this. Okay, hold on. Wouldn't we be able to rewrite this by saying 2 cubed, because we've got 3 on top, and then 1, 2, 3, 4, 5 on bottom. 2 to the 5th. But that's kind of a lot going on. 2 to the 3rd and 2 to the 5th. Okay, could we simplify this a little bit further? I'm wondering, what if we crossed out this one and this one, because the same number on top and bottom could cancel each other out, right? Like, okay, just a second. What if we did something like 3 over 6. What if we did something like that? Couldn't this be simplified? If we simplified this, like I'm thinking like divide by 2. Oh, sorry, that was kind of a bad. Divide by 2. Divide by 2. Wouldn't this equal, wouldn't this end up being, what's this, 3? Wow. Instead of divide by 2, how about divide by 3? Sorry. Divide by 3, divide by 3. Wouldn't that end up being a 1 on top, and then this would end up being a 2? So 3 over 6 ends up being 1/2. Okay, along the same lines, I'm thinking, what am I thinking? I'm thinking, I don't know, hold on. 2 and 2, those cancel each other out. 2 and 2, these cancel each other out. So it kind of looks like we canceled everything out on top, and there should be a 1 or 0, but it's actually a 1 on top, because here, you know how we canceled out the 3's? 3 divided by 3, we ended up with a 1. So here too, even though all of these cancel out, we end up with a 1. And then these cancel, 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 we end up with 2 2's on the bottom. So it ends up being 1 over 2 times 2. So I'm going to say 1 over, what's 2 times 2? You could say, oh, it says use an exponent. Hold on. So I'm going to say 2 squared. You could do 1 over, what's 2 squared? 2 squared is 4, right? So you could say 1 over 4. So I feel like the answer would be 1/4, but it says use an exponent. So this would be our actual answer because it has an exponent on there. Anyway, let's see. We're going to go into these examples here. Let's see what we can do with these. That was kind of a warm-up activity, but we're going to do some more practice here throughout this lesson. So, this is talking about snowflakes. Using our table, how many times as great is the diameter of snowflake C than B? How many times as great is this than this? In order to do that, thinking out loud, wouldn't we do C divided by B? So C is 1, B is 0.1. Plug that into your calculator. What do you get? 1 divided by 0.1, or 0.1. That gives me 10. So that's 10 times as great. 10 times as great. How about this next one? How many times as great is the diameter of C than A? C is 1, so I guess I put a 1 here. A is 0.01, 0.01. Okay, let's do that. Plug that into your calculator. Grab your calculator. 1 divided by 0.01, that's 100. So it's 100 times as great. This is saying here, snowflake C is 100 times bigger than this tiny little snowflake A. Oh, now it says write this number using an exponent. Okay, so an exponent, think about this. What times what gives 100? What number times itself gives 100? Isn't it 10 times 10? So for this one, we could say, write this number using an exponent. 100 is equal to 10 times 10, or in other words, 10 squared. 10 squared, okay. How about this next part? The diameter of snowflake B is 0.1 times as great as the diameter of C. Write this as a fraction. So we're supposed to write 0.1 as a fraction. 0.1. Isn't that, we would say that as 1/10. Another way to do this, plug it into your calculator. So if you type 0.1, I'm going to blow this up here real quick. So if you type in 0.1 into your calculator, hit the fraction button. So for me, this is the food button here. So I'm going to click second, and then I'm going to click this PRB because it has the food button right above it. So fraction to decimal. And then hit enter, and it says 1/10. Okay, that's how you can use your calculator to help you solve this. Alright, so this gives us 1/10, so I'm going to say 1/10. It says here the diameter of snowflake A is how many times as great as the diameter of snowflake C. A is how many times as great as C. Okay, so I guess we would be doing 0.01 divided by 1. 0.01 divided by 1. When we plug that into our calculator, we just get 0.01, right? Anything divided by 1 is the same, doesn't change the value of the number. Guess that's our answer. Write this number as a fraction. Okay. Use your calculator, 0.01, and do that fraction to decimal button. When you do, take a minute, hit pause if you need to. When you do, I believe you get the answer of 1/100. 1/100. It says here, write the fraction with an exponent in the denominator. Alright? Well, we already did 100 as an exponent. Do you remember this? So when we wrote 100 with an exponent, and it ended up being 10 times 10. So here, if we're writing that fraction with the exponent in the bottom, so we'd say 1/100, or in other words, 1/10 squared. Sorry, that's supposed to be a 2. Does that look like a 2? I hope it looks like a 2. Sorry. Okay. Now it's asking us to complete this table. So this is saying here, the number 1000 could be rewritten as saying 10 to the 3rd power. So that's 10 times 10 times 10 gives 1000. How about 100? 100 is 10 times 10, so 10 squared. The number 10, I guess if you want to write it with an exponent, it would just be to the 1st power. Anything to the 1st power doesn't change the value of the number. So you could say 37 to the 1st power. The answer is 37, you know? Okay, so 1 could be written as 10 to the 0 power. 1/10 would be 10 to the negative 1st. 1/100th, what do you think would go here? I think if we continue this trend, couldn't we say 10 to the negative 2nd? So this one would probably be 10 to the negative 3rd. Alright, so this says predict how to write this using a negative exponent. So I feel like this one, let's start with our x value. Check this out. So using a negative exponent. 1 over this guy, 1 over this guy, ends up being this, written with an exponent, but we make the exponent negative. So in this case here, what I'm going to do here, I'm going to do x to the 4th. I'm going to say x to the negative 4th. There we go, x to the negative 4th. Okay, that's kind of tricky. Alright, we're going to get some more practice here. So this is kind of stepping us through some of the examples. We're going to do a lot more practice right here. So, hey, just a heads up, I don't think we're going to get through this all in one video, so be sure to check out the next video for more examples here. So for this one it says circle the correct answer. So we've got 4 to the negative 3rd power. Okay, thinking out loud, wouldn't this be the same as 1 over 4 to the 3rd? So what is 1 over 4 to the 3rd power? Type in 4 times 4 times 4 to your calculator, or 4 to the 3rd power. What do you get? It should be this guy, 1 over 64. All right? How about the next one? Sorry, this one's next. 6 to the negative second power, okay? 6 to the negative second power would be the same as saying 1 over 6 to the second power. So 1 over 6 to the second power. Well, what would this be? 6 to the second power is 36. So it's got to be this one. Let's do another one. 1 over 25. 1 over 25. This would be the same as, I'm going to switch colors on us here. So let's do pink. So 1 over 25 would be the same as saying 1 over what times what? What's the square root of 25? In other words, what number times itself gives us 25? Isn't that 5 squared? Okay, so you could say 1 over 5 squared. That's not an option. There's a negative here, but that's not what we want. So 1 over 5 squared, this would be the same as saying, if we want to flip this to the top, then this becomes a negative exponent. So 5 to the negative second. So it looks like this one would be our answer. Let's do another one. So 216. This would, you'd probably need to do the cubed root of this. You can do that on your calculator. So on our calculator, I'm going to blow this up so you can see me a little bit better. Okay, so on our calculator, you can do cubed root. What you need is this caret button here. Do you see that it has the cubed, sorry, it has an X and a square root button? So what we're going to do is we're actually going to type the 3 first because we want to say 3. And then what we're going to do is we're going to say 3 and then press the second and then this button here. When we press the second button and then this lets us say cubed root. So then we type in 216. So the cubed root of 216, and then when you hit enter, sorry guys, when you hit enter, it ends up saying 6. So again, 3, second, this button, second, and then this button, and then 216, hit enter, and you should get 6. If you've got questions, please email, and we can go through it during a Google Meet if we need to, so I can help talk you through how to do that. Okay, so the answer is 6. So that means for this, we would be saying this is 1 over 6 to the third power. And then to flip this to the top number, sorry, to the top side, that means the 3 would end up being negative. So we would say 6 to the negative third. 6 to the negative third. So that means, sorry, this one is our answer. Alright, let's do another one. So let's do this one here. So this says 3 to the negative fourth. So 3 to the negative fourth would be the same as saying 1 over 3 to the fourth. So you can plug that into your calculator. So you can plug in 3 to the fourth in your calculator and see what you get. And I'm assuming it's 81. So it'd be 1 over 81. In this case, we're saying here 1 over 32. So this would be saying 1 over something, okay, 32. Well, they're giving us these answer options of 2 to the 5th. I think if you plug this into your calculator, test it out, but I think this is 2 to the 5th power. 2 to the 5th power. Check in your calculator. Does that work? 2 to the 5th power. Is that 32? If so, then 1 over 2 to the 5th power would be the same as saying 2 to the negative 5th power. I know this is tricky, guys, because the exponent has a negative, so it seems like something in our answer should have a negative here. Okay, so sorry, this one should be it. It seems like the number out in front should have a negative at some point, but we're only dealing with the exponent in this case. We're not messing with the positive or negative of the number out in front. Okay, so we're going to tackle this next one in the next video. So I'm going to stop right now and then check out the next video to finish our homework, or the practice problems here. Okay.